Hey guys, good morning. I hope everything's going well. I'm over here in Indianapolis at the National Council of Teachers Mathematics Convention. I'm having a blast. It's awesome. There's so much stuff to do here. There's so many classes that I'm going to. I'm learning so much that I can't wait to share with you. There's one thing that we're going to be going over today that you guys are going to be working on in class, a little bit of exploration for you to work on throughout the week, and then whenever you come back to class next week and we get together, then we're going to take this one step further. So I thought I'd get started. I got a board here so we can work together. You guys are going to need a sheet of paper, so you can pause here if you need to get a sheet of paper and a pencil, but we're going to be working on this together. This is what they call Pascal's triangle, and we're going to be building this together. So you're going to start off by making a 1 on top of your paper, and we're going to be building a triangle in this way, and there's just really two rules that we go with. So we're going to start off with a 1 on the outside of every row, and then for the insides we just add together the two numbers that are on top of it, and with those two rules we can fill the whole thing in. So for example, in this space the two numbers on top of it would be a 1 and a 1. So when we add those together, this new number would be a 2. And then we have 1s on the outside. Follow those two rules. 1s on the outside, and every one on the inside is the sum of the two numbers above it. So we'll have a 1. 1 plus 2 is 3. 2 plus 1 is 3. And then a 1 on the outside. And then we'll do one more. We'll have a 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, and a 1 on the outside. So carrying that through, I've got a huge list of, this goes all the way through 1 and 10 being your next number. Now, as you'll carry this out, there are going to be a ton of patterns that you are going to notice. There are a few that I want to point out. I also want to name just a few of them and see if you can find them. And then we're going to be using this to our advantage for several different things whenever we are working on it. So, to start off with, we have the natural numbers occurring here. And where they occur is if you go right down this diagonal, then we'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way down. So the natural numbers occur on here, pretty easily to find, just straight down this little diagonal line on the end, right next to the 1s. The whole numbers are on there also, with a little bit of creativity. So I want to see if you can find the whole numbers. So that is going to be the first one, your challenge for you to find. Where could we find the whole numbers? And remember, the whole numbers are like the natural numbers, but the whole numbers are how many pets can you have? 0, 1, 2, 3, 4, the whole numbers. Alright, the next thing that I want you to take a look at is we would call each way that we go across a row. And I want you to figure out, well, what happens if I take the sum of the row? For example, the first row has a sum of 1 because it's just 1. And then the second row is going to have 1 plus 1, which is going to give me 2. As you carry that down, it's going to create some sort of a pattern. What is the pattern? So that's going to be the sum of the rows. Rows are going to go across left to right. What happens when you add them up? You're going to tell me that. Alright, the next thing that I want to check out is we're going to do basically the same thing. We're going to go across the rows. But what happens if instead of just adding all the way across, what if we were to flip-flop back and forth between adding and subtracting? Well, let's try it. So let's say we add a 1. Well, then we just got a 1. What if we added 1, then subtracted 1? Well, that'd be a 0. What if we added 1, subtracted 2, and then added 1? Or added 1, subtracted 3, added 3, subtracted 1? What would that give me? I want you to try that. See if that develops any pattern. What if you add, subtract, and keep going with it? Well, what about the other way? What if you subtract, add, all the way through? What kind of patterns do we get there? I want you to try those two out also. And then there's one other pattern that I'm going to get you to look at on your own before we meet next week. I want you to go through, create a Pascal's triangle. You're going to need 2 of these because you're going to be marking it all up. And I want you to go through and I want you to look at the numbers that are divisible by 2. Now, each particular number in this triangle we would call an element. So I want you to say, well, which elements are divisible by 2? Well, 2 is divisible by 2, for example. What else can you find that's divisible by 2? See what that looks like. And once you try out divisibility by 2, I told you needed 2 triangles. The other one I want you to try is divisibility by 3. See what kind of a pattern that's going to give you. And whenever you get back to class next week and we meet together, I want you to have these along with the rest of your packet filled out and we can discuss these.